Welcome to BrilliantMaths.com, where every student has an opportunity to excel in maths. Have you subscribed to BrilliantMaths.com yet? Do so. You'll be glad you did. There are lots and lots of resources for primary and secondary school students. You have an opportunity to improve your grades. Today's lesson is actually taken from Brilliant Maths Module 2. Get a copy and let's work together. Today we're looking at fractions, introduction to fractions. Specifically, we're looking at types of fractions. There are two main types of fractions, proper fraction and improper fraction. A fraction is either proper or improper. But what is a fraction? A fraction is a part of a whole. A fraction is a part of a whole. That's a simple definition of a fraction. Then, a proper fraction is a fraction in which the numerator is smaller than the denominator. Examples of proper fractions are half, 2/3, 4/5, 11/20, and so on. So when you have a proper fraction, the numerator is smaller than the denominator. While an improper fraction is a fraction in which the numerator is larger than the denominator. Examples of improper fractions are 3/2, 5/4, 101/5, 20/11. You can see that in all these fractions, the numerator is larger or bigger than the denominator. Here we want to look at how to change improper fractions to mixed fractions and mixed fractions to improper fractions. Example 1. Write 15/4 as a mixed fraction. 15/4 is an improper fraction. We can see that the numerator is greater than the denominator. So we want to change this improper fraction to a mixed fraction or a mixed number. In some books, you'll find it as mixed fraction or mixed number. It only means it has a whole number part and a fraction part. So 15/4. 15/4 is equal to 15 divided by 4. So we're dividing 15 by 4. How many 4s do you have in 15? 3. 3 times 4 is 12. You subtract. 15 take away 12 is 3. So 15/4 is equal to 3 wholes and 3/4. So that is 3 whole number, 3/4. We have changed 15/4 to a mixed fraction. In the second example, write 5/3 as an improper fraction. 5/3 is equal to, you multiply the whole number by the denominator, 5 times 4, and then add the numerator over 4. So the process is multiply the whole number by the denominator and add the numerator and put everything over the denominator. So 5 times 4 is 20. 20 plus 3 is 23/4. So 5/3 is the same as 23/4 as an improper fraction. Here we want to look at equivalent fractions. Equivalent fractions are fractions that have the same value. Although the denominator and numerator numbers might be different, it might look different, but in the real sense of it, the fractions have the same value. Examples of equivalent fractions are 4/8, 2/4, 3/6, and a half. All four fractions actually have the same value. Let's see that. We have half, 2 halves make a whole, 1, 2, 3, 4, 4/4 make a whole, and 8/8 make a whole. So we want to show that 2/4 is equal to a half. So we have a half there. And let's see. As you can see, it fits perfectly. Perfect. So 2/4 make a half. So they are equivalent. And then let's show that 1/2 is equal to 4/8. So we take that half equal to 4/8. And it fits exactly. So we can see that a half is equivalent to 2/4 and is equivalent to 4/8. That's very interesting. And you can practice this. Take 2 loaves of bread, cut one into two equal parts, because for fractions, the parts must be equal. Cut one loaf into 2 equal parts, and take the other loaf and cut it into 4 equal parts. If you take 2 of the 4 and 1 of the half, you'll find out that they are equal. Those are equivalent fractions. We're still looking at equivalent fractions. We want to be able to check if 2 fractions are equivalent, and also to be able to find a fraction that's equivalent to another and build a family of equivalent fractions. So for the first example, it says show that 16/20 is equivalent to 40/50. So to show that 2 fractions are equivalent, you reduce both fractions to their lowest terms. It's as simple as that. So 16/20, both of them can be divided by 4. 4 is a factor of 16. So if we divide by 4, it gives us 16 divided by 4 is 4, and 20 divided by 4 is 5. So 16/20 in its lowest term is 4/5. And also, we know that 40/50 in its lowest terms, if you divide both of them by 10, is 4/5. So both of them are equal to 4/5. So we can say that they are equivalent. So we've just shown that. Example 2. Find the missing number. 2/6 is equal to what over 18? What should be written as a denominator? So 2/6. The 6 is now 18. We divide 18 by 6 to get the multiplier, and that is 3. 18 divided by 6 is 3. So you simply multiply 2 by 3 to get what the denominator should be. So 2 times 3 is 6. Therefore, 2/6 is equal to 6/18. And if you want to check if both of them are equivalent, let's reduce them to lowest term. If you divide that by itself, you get 1. 6 divided by 2 is 3, so that's 1/3. And also, 6 in 6 is 1, and 6 in 18 is 3. So as we can see, to 6 is equivalent to 6 over 18. That's how to find the numerator, or the missing number in equivalent fractions. And then lastly, we want to write 4 fractions that are equivalent to 2/5. We want to build a family of equivalent fractions. How do you do that? You simply multiply that fraction by the same number. Multiply the numerator and the denominator by the same number, and it will be equivalent. So let's go. 2 times, we could start with 2. 2 times 2 over 5 times 2. That will give us 4 over 10. Next, 2 over 5. We could do 2 times 4 over 5 times 4. 2 times 4 is 8. 8 over 20. We can also do 2 over 5. 2 times 3. Multiplying numerator and denominator. Multiplying numerator and denominator by 3. So that will give us 6 over 15. And finally, 2 over 5. Let's say 2 times 8. And 5 times 8. And that gives us 2 times 8 is 16. And 5 times 8 is 40. So it implies that 2 over 5 is equivalent to 4 over 10. 2 over 5 is equal to 4 over 10, and is equal to 8 over 20, and is equal to 6 over 15, and that's also equal to 16 over 40. So we have been able to write 4 fractions that are equivalent to 2/5. You can get more of this from Brilliant Maths Module 2. In this part of the lesson, we want to learn how to compare and order fractions, real life. So for example, which is greater, half or 1/3? Assuming you cut a loaf of bread into 2, each part is a half, and you cut another loaf of bread of the same size into 3, each part is a 1/3. Which will be greater? The half will be greater than the 1/3, because the less the number of parts you cut it, the bigger the portion. So half, 1/2 is greater than 1/3. In the second example, write 2/7, 5/7, 1/7, and 4/7 in ascending order. The denominators are the same, as you can see. It has been cut into 7 parts. So somebody who gets 1 part and somebody who gets 5 parts out of 7, definitely 5 parts is more. 5 parts out of 7 is more than 1 part out of 7. So in ascending order, so from smallest to largest, in ascending order, we have the smallest is 1 over 7. The next is 2 over 7. And then 4 over 7 and 5 over 7. So when the denominators are the same, the bigger the numerator, the bigger the fraction. And the smaller the numerator, the smaller the fraction. When the numerators are the same, the smaller the denominator, the bigger the fraction. So take note of that. You could try cutting paper or cookies into equal parts and use that to consolidate your understanding. Example 3, which is greater? 4/5 and 2/7. There are several ways you can compare this. We could do this by simple observation. 4/5 is greater than half, and 2/7 is less than half. So we definitely know that 4/5 is greater than 2/7. That's one way, simple observation. Secondly, you could cross multiply 4 times 7 and write it on the left-hand side, which is 28. Let me write that out. 4/5 and 2/7. 4/5 or 2/7, which is greater. If I cross multiply 5 times 2, and that is 10, I write it on the right-hand side, and 4 times 7, which gives me 28 on the left. 28 is greater than 10. So 4/5 is greater than 2/7. I've just used two methods there by checking if one is greater than half or less than half, and also by cross multiplying. Another method might be to find the LCM, make both of them the same denominator, and find their equivalent fractions. So we'll do that in example 4. Arrange 4/9, 2/3, 3/7, and a half in ascending order. Before we can compare, we need to find a common denominator for all the fractions. So we find the LCM of 9, 3, 7, and 2. And that LCM is 126. So next, we divide the LCM by each of the denominators, and then multiply each by the numerator to find the equivalent fraction. So 126 divided by 9. 9 in 12 is 1. Remember 3. 9 in 36 is 4. So that's 14. So 14 times 4 equals 56. So 4/9, or 4/9, is equal to 56 over 126. That's the equivalent fraction. 126 divided by 3. 3 in 12 is 4. And 3 in 6 is 2. So that's 42. 42 times 2 is 84. So 2/3 is equivalent to 84 over 126. 126 divided by 7. 7 in 12 is 1. Remember 5. Into 56 is 8. So 18 times 3. 18 times 3. And that's equal to 54. So 3/7 is equivalent to 54 over 126. And then the last fraction is half. 126 divided by 2 is 63. So now all 4 fractions have a common denominator. So we can order them. We're ordering in ascending order. So we're starting with the smallest to largest. So of these fractions, the smallest is 54 over 126. And 54 over 126 is 3/7. So the order is 3/7. The next is 56 over 126, and that is 4/9. The next is 63 over 126, and that is a half. And the last one is 84 over 126, and that is 2/3. So that's the order in ascending order. So to be able to compare the fractions, you must find a common denominator, the lowest common denominator. You express all the fractions with that denominator, and then you can compare. Very easy. Try some more from Brilliant Maths Module 2. In this part of the lesson, we want to learn how to add fractions. We're adding 5/8 to 6/11. So 5/8 plus 6/11. We have to find a common denominator, or LCM. So the LCM of 8 and 11 is equal to 88. So there are two ways. You can find the equivalent fraction of 5/8 with a denominator of 88, and the equivalent fraction of 6/11 with a denominator of 88, and then add them together. Or put them under a common denominator, which is 88. 8 into 88 is 11. 11 times 5 is 55. Plus 11 into 88 is 8. And 8 times 6 is 48. We then add 55 and 48. 5 plus 8 is 13. Carry 1. 1 plus 4 is 5, and 5 plus 5 is 10. So we have 103 over 88. This is an improper fraction, so we need to change it to a mixed number. How do we change that to a mixed number? By dividing 103 by 88. How many 88s would you get in 103? It's just one. So we subtract. 13 minus 8 is 5. And we're left with 9 there. 9 minus 8 is 1. So the final answer is 1 whole number, 15 over 88. That's very simple. In the second example, we have 4 1/3 plus 6 2/7. You add the whole number part together, 4 plus 6, which is 10. And then we have to find the LCM of 3 and 7, which is 21. So using the same method, 21 as a common denominator for both. 3 into 21 is 7. 7 times 1 is 7, plus 7 into 21 is 3. 3 times 2 is 6. And that gives us 10, 13 over 21. And that's the final answer. Assuming we had a numerator that is greater than the denominator, giving us an improper fraction there, you have to convert that improper fraction and add the whole to the 10. Get some more examples from Brilliant Maths Module 2. Here we want to look at how to subtract fractions. The first example is 5 3/5 take away 2 1/3. I want you to pay particular attention to the difference between the two problems. 5 3/5 take away 2 1/3, and 3 1/3 take away 1 3/4. What do you notice? The proper fraction attached to the whole numbers is what I want you to take note of. For example, 1 and 2. We'll see the difference as we go on. So solution. Five 3/5 take away 2 1/3. I usually advise my students not to change them to improper fractions before subtracting, because when the numbers get large, it can be very difficult. So subtract the whole numbers. 5 take away 2 is 3. So you find the LCM of the denominators of 5 and 3, and that is 15. 5 in 15 is 3. 3 times 3 is 9. Take away 3 in 15 is 5. 5 times 1 is 5. That means that 3/5 is equivalent to 9 over 15. And 1/3 is equivalent to 5 over 15. So our final answer is 3 whole number. 9 minus 5 is 4 over 15. In the second example, let's take the solution. We have 3 1/3. 3 1/3, take away 1 3/4. 3 take away 1 is 2. LCM of 3 and 4 is 12. 3 in 12 is 4. 4 times 1 is 4. Minus 4 in 12 is 3. 3 times 3 is 9. So here, we're subtracting 9 from 4. Since 9 is bigger than 4, we'll borrow 1 from the 2, from the whole number. And the value of that 1 is 12 out of 12. So what we have now is 1, 4, plus 12. Take away 9, all over 12. So the one you borrow would usually have the value of the denominator over itself. 12 out of 12 is 1. So we have added the 1 we borrowed to the 4 so we can subtract. So this becomes 16 minus 9. And 16 minus 9 is 7. So our final answer is 1 whole number, 7 over 12. This was what I wanted you to take note of, where you have to subtract a bigger number from a smaller one. Because you have to do that, you need to borrow from the whole number to be able to effect the subtraction. So take note of that and practice some more from Brilliant Maths Module 2. Did you enjoy this lesson? You can get more at brilliantmaths.com. Subscribe to brilliantmaths.com and you'll be glad you did. Brilliantmaths.com is here to ensure that you excel in maths. My name is Ngozi Orevon, and always remember that maths is fun and you can do it.